So this is just kind of a quick refresher of 5.1, especially if you struggled on the quiz or you've been struggling with the homework or whatever. It's not clicking. So just kind of a quick run through again to go over the topics that we talked about in that section. The first thing you have to know that I think some of you are struggling with is what a perpendicular bisector is. And then that also leads to the issues with the perpendicular bisector theorem. So here's out of the book. The perpendicular bisector is a segment that is also perpendicular and it bisects the segment. It does both those things at once. So you can see here, PQ bisects AB, but it's not perpendicular to it. RS right here is our perpendicular bisector because it cuts it in half and it's perpendicular to it. The other thing I think it's throwing you off is some of you think that it should go through something special in the triangle, and it doesn't necessarily have to. For instance, right here, this drawing in the picture to the bottom left of the screen, this segment is the perpendicular bisector. It's perpendicular to xy, and it cuts it in half. Makes x to this equal to this to y. So that's the perpendicular bisector. Now the perpendicular bisector theorem then states that if you are on the perpendicular bisector, if you're actually on it, then any point on the perpendicular bisector, like this point C here, is the same distance from A as it is from B. Okay. So A to C is the same length as B to C is. And then the converse just flips it. It says if you are equidistant from the endpoints, and you're on a segment that's perpendicular to it, it must bisect it as well. Okay. So that's all it states, those two things. And the other theorem that deals with this is when you have all the perpendicular bisectors of a triangle, all three of them drawn at once, like in this case here, the red segments are the perpendicular bisectors. So D to P, P to E, and PF. All of those are perpendicular bisectors. They all meet at point P, and since you're equidistant from the endpoints of the segment, if you're on the perpendicular bisector, that means you're also now equidistant from the three corners or vertices of the triangle. And on the quiz, some of you guys said angles, and even though I know what you meant, you can't really be equidistant from an angle. You're equidistant from a point. Now the next theorem on the next video I'll do, you can be equidistant from the sides of the angle, but not the angles themselves. So let's look at some examples to kind of walk through how this works. So again, perpendicular bisector is a line or segment or array that is perpendicular to a given segment and it passes through the midpoint. So it's perpendicular to it and bisects it. And if you're on the perpendicular bisector of a segment, then you are equidistant from the endpoints of the segment. If a point is equidistant from the endpoints of a segment, it has to be on the perpendicular bisector of the segment. And then the circumcenter is the perpendicular bisectors of the sides of a triangle intersecting at a point called the circumcenter, and it's equidistant from the vertices of the triangle. So examples. So number one here. Okay. I am told that XZ is perpendicular to YW by the right angle in the drawing. I also know that YZ and WZ are congruent because they're both 5 in length. So that means that this segment XZ is the perpendicular bisector of WY. Meaning, any point on that, I could have this point here, this point down here, they're the same distance from the endpoints, which means X is the same distance to Y as it is to W, so XW is 7.5. Now 2 is the flip of that. I know point E is the same distance to F as it is to A. From E to F is the same distance as it is from to E to A. They're both 19. And I also know that EB is on the perpendicular to AF. So if it's equidistant and it's on the perpendicular line, it must also bisect it, meaning that BF is 4.2 as well, since AB is 4.2. On this one here, again, you have the circumcenter, which means you have the perpendicular bisectors. So, if I look at the drawing then, I know that these lines are all perpendicular to their sides, that's given, but they also bisect them. And I also know that point P is the same distance from all three vertices, because that's what's special about the circumcenter. So I have a lot of stuff that's congruent in this drawing. So the question is, name all the segments congruent to segment MY. Well, y is the midpoint of EM, so MY is congruent to YE. Okay. That's it. KP. KP is the segment that connects the circumcenter P to K. So that's the distance from the circumcenter to the vertex. Oh, there are three segments that are congruent there. KP, MP, and EP. MN, well, that's a segment that's part of a side that's been perpendicular bisected by segment EN, so it has to be equal to NK, because that's the other part of it. And then ER, same thing as 3 and 5. ER is congruent to KR. And there's a quick review of the perpendicular bisector theorem and the circumcenter.